What we have discussed in last lecture? Yes, we started the ER diagrams, how to create entity relationship diagram. Okay, we follow these steps. That is that determines first of all entities, then add the attributes, identify the relationships, and complete the diagram. Hmm? Okay, and we have taken one example which is related to the company and apply these three steps. Hmm? Step 1 and step 2 is what identifies the entities and find out, add the attributes to that entities. Okay, the next step is third step, that is the find out the relationship between the entities. Okay, see, this is the most important concept. Hope so you all understood this concept. Hmm? And from given request statements, requirement statement, we create the ER diagram of a company. Okay, this is the complete ER diagram. Okay, after that we have seen the ER diagram design issue. There are basically four design issues related to the ER diagram. Okay, use of entity set versus attributes, use of entity sets versus relationship set, huh? Then use of binary versus Android relationship set, and the fourth one is the placing relationship attributes. Okay, is there any doubt in these points? Otherwise we will start the new points. Yes, is there any doubt in ER diagram, how to create ER diagram? This is your first assignment. Okay, from a given requirement statement you have to create the ER diagrams. So if is there any doubt, let me know here only. Okay, the new point is extended ER features. Okay, it's also called as EER features. See, the ER model has the power of expressing database entities in the conceptual hierarchical manner. We can represent the ER model in a hierarchical formats too. Hmm? This is the one of the base feature of the ER model, and this is the extended one. It's not a basic; it's a advanced layer ER modeling, or it's a extended ER features. See, hierarchy, that is the tree format, tree structures. Okay, there is a main entity, and after that there is a sub entity, or there is a one main class in related to the object oriented programming, and below that sub classes, uh, below that main classes sub classes are there. Okay, which are inheriting the main class properties. The same concept is followed over here. As a hierarchy goes up, it generalizes the view of entities. Okay. In extended ER feature, we will see two most important concepts. These are the generalization specializations. Okay, note it down. Okay, see, generalization is nothing but going up in this structure where entities are clubbed together to represent more generalized view. Hmm? Means we are creating our structure entities to a more generalized view, then it's called as a generalization. For example, hmm, particular students name XYZ can generalize along with all the students. Okay, the entity shall be student, and further the student is a person. Okay, see, student is the specialized form because we are categorize it into the from person to student, and if we want to make it more generalized, then we can group or club into the person. Okay, are you getting, students? If there is a structure, and if you are clubbing together these structures, for example, uh, sparrow, parrots, huh? These are the form of birds. We are creating the entities for the sparrows, huh? Entities for the parrots, pigeons, huh? But all these comes under the category of the birds. Then birds are the generalization of the sparrow, parrots, and these specialized category. Okay, are you getting, students? That means clubbing, we are clubbing the property entities, sorry, we are clubbing the entities together to to represent more generalized view. Okay, see, students also one entity, teachers also one of the entity, as well as the non-teaching staff, this is the another entity. Okay, in the university database, if we these different kind of entities, if we are clubbing together, we are grouping together and making the one entity, which is more generalized, hmm, that is the person, then this is nothing but the generalization. Opposite to generalization, that is the specialization. For example, a particular student's name XYZ can be generalized along with all the students. The entity shall be student, and further the student is a person. Then reverse is called specialization. When a person is a student and that student is a XYZ. Let's see generalization in more detail. See, generalization is a bottom up approach. Note down these points. Okay, note down these points. Today's session, your unit 1 will get over all the points we will cover in today's sessions. Hmm? Monday or Tuesday, there is a test, unit test 1, okay, on unit 1. Generalization. It is a bottom up approach in which two or more entities of a lower level combine to form a higher level entity if they have some attributes in a common. Hmm? From bottom to top, we are going from bottom to top, that's why it's called as a bottom up approach. Okay, here we are combining the lower level entities. See the diagram. In this diagram, faculty as well as the student, these are the lower level entities, and it is become a, after combining these entity, that is the generalization is the person. Okay. In generalization, an entity of a higher level can also combine with the entity of the lower level to form the further higher level entity. Okay. See, higher level entity it's called as a superclass, and the lower level entities it's also called as a subclass. Hmm? Here, faculty and students are the subclasses of the person. Okay. In generalization, entities are combined to form a more generalized entity. That is, subclasses are combined to make a superclass. Collection of the subclasses becomes a superclass. Okay. Now over here there is a diamond is a, which represent the generalizations. Okay. Um, Instead of that, you also can use triangle, which shows the generalization. This also shows the generalization. Both are okay. Okay. You may use the triangle or a diamond to show the generalization. Okay. Hope so you understood the concept of the generalization. Is there any doubt? Just draw the diagram, note down the important points. Yes, is there any doubt? Okay. Next is the next point, that is the specialization. Opposite to generalizations, it's the specializations. Specialization is a top down approach. That means we are coming from the top level to the lower level, at a down level. It's a opposite to the generalization. In a specialization, one higher level entity can be broken down into a two lower level entities. Now look into the diagram. Here higher level entity is the employee, and the lower level entities are the tester, developer. Okay, employee may be a tester, employee may be a developer. That means we are broken down, we are categorize the employee again into the subclasses, that is the tester as well as the developer. It may have the more categories like manager, CEO, like that. Then specialization is used to identify the subset of the entity set that share some distinguishing the characteristics. Okay. For what purpose we are using the specialization? To identify the subset. Okay. Then normally the superclass is defined first Over here, the superclass is defined first because it's a top-down approach. So we have to define first superclass. Over here, employee is the superclass, and then the subclass and related attributes are defined the next. Okay, and after that, the relationship set is then added in between these entity. Okay, are you getting, students? Generalization, specializations. We are on the point of the extended ER features. These are the two important points in that. Just note down specialization concept as well as the draw the diagram. Write down the superclass, subclass in that diagram. I will wait for the 2 minutes. Yes, over. Okay, move to the next slides. That is the inheritance. Hierarchy is the one of the feature of the ER model. So feature of ER model in order to create the classes of object in the object oriented programming. Hope so you know aware of the object oriented programming, that is the C++, Java. Okay, these languages are based on the object oriented. Okay, and inheritance is the one of the feature of object oriented programming languages. Okay, anyone knows inheritance? See, there are the superclass and then the subclasses are there, and we are inheriting. We are taking the properties, some properties from the superclass to the subclasses. So this is nothing but the inheritance, as well as we are hiding some details of the entities. Huh? And generally, and these details are hidden from the user. So this process is known as the abstraction. Hiding some details from the users, it's called as a abstractions, and this is possible because of the inheritance only. Okay, inheritance is an important feature of a generalization as well as the specialization. It allows lower level entities to inherit the attributes of a higher level entities. See over here, look into the diagram. Now here, person is an entity with its attributes, name, age, as well as the gender. Okay. Now, student is one of the entity. Teacher is also entity. Okay. Student as well as teachers. These are also entities. Listen carefully now. Now, person with its unique attributes are the name, age, as well as the gender, and students and teacher. Okay, student and teacher are at a lower level, at the bottom side, and person is at quite obvious at the top level because it is more generalized entity. Okay, and students and teachers are the specialized entity. Okay, so person can be categorized into the student, teachers, employee, like that. So here person is the superclass, students and teachers are the subclasses, and uh, as student and teachers are the subclasses of the superclass student person, so because of that we can inherit the attributes of the person into our students. Means we can use the name, age, gender, as well as the roll number as an attribute of the students too. Here in teacher entity, we can use the name, age, gender, as well as the employee ID as the attributes of the teacher. Okay, that means name, age, gender, these are the attributes of the person, but we are inheriting, okay, these properties with the other entities which are the subclasses of the superclasses. Are you getting, students, or not? Hello, I am asking to you, are you understood? What is the main purpose of the inheritance, specialization, generalizations? Or may I repeat?
Repeat, ma'am.
Okay, one more time, I will repeat. First of all, are you understood the concept of the generalization and specializations? As the name suggests, generalization, it's a common one, and specialize means from generalize and what is the generalized entity? For example, person, employee. Huh? We are going to in more deep and categorize these entity into the subclasses. Okay, up to this, are you clear with the concept?
Yes, ma'am.
Okay. No. Now, suppose uh, if first of all, now exclude the person. Only over here, student as well as the teacher. These two entities are present. Consider these two entities only. Now, as a student, it may have different attributes: roll number, name, age, as well as the gender. These four attributes. Okay. As a teacher, also entity. It may have the attributes employee ID, name, age, gender. Means in these two attributes, some attributes are common and some attributes, few attributes are the different. Because of that, we are categorized these two into a separate one. Up till now understood? Okay. Students has a four attributes: roll number, name, age, gender. These are the four attributes of the student entity. As well as the teacher also having the employee ID, name, age, gender. Okay. But in these two entities, some attributes are common. Which are those? Name, age, gender. Okay. And some attributes are different. For students, roll number, concentrate now on a diagram. Student has a different attribute, that is the roll number, and teacher has the different attribute, that is the employee ID. But these two, we if we combine, because then it comes under the uh, more generalized view, that is the person. And whatever are the common properties, we can add that property with the person, that is the name, age, gender. What's the purpose of this? Here the student and teachers, if we have to define these property two times, but because of the generalized view, we have to define these property only one time, and we are sharing these data with student as well as the teacher. Okay, that means name, age, gender, these are the common attributes, common properties, and we are using these attributes with the student too as well as the teachers too. That means we are inheriting, we are inheriting the properties of the common entity with the specialized entity. समजतंय का की नाही समजत आहे?
Yes, ma'am. Clear now.
ओके, थँक्स फॉर द रिप्लाय पल्लवी. एव्हरीवन, का मराठीमध्ये सांगू थोडंसं की अजून समजेल? Is it clear? Everyone? इथे स्टुडंट आणि टीचर ह्या दोन आहेत. का आहेत? स्पेशलाइज कॅटेगरी आहे ती. ओके. अँड आपण ह्या दोन ज्या आहेत एंटिटी क्लब करू शकतो कॉमन व्ह्यूसाठी, जनरलाइज व्ह्यूसाठी टू द पर्सन. त्याचा पर्पज असा आहे की जो आपण रिपीटेड ॲट्रिब्यूट्स आहे ते एकदाच डिक्लेअर करू शकतो. दॅट इज कॉल्ड ॲज अ इनहेरिटन्स. म्हणजे आता पर्सनच्या ज्या प्रॉपर्टीज आहेत, नेम, एज, जेंडर, त्या प्रॉपर्टीज आपण स्टुडंट्सला सुद्धा अप्लाय करू शकतो. मग स्टुडंटच्या प्रॉपर्टीज काय झाल्या, ॲट्रिब्यूट्स काय झाले, रोल नंबर, नेम, एज, जेंडर, ॲज वेल ॲज टीचरचा इथे एम्प्लॉई आय डी दिसतो आहे आपल्याला. बट वी कॅन ऑल्सो अप्लाय नेम, एज, जेंडर टू द टीचर्स टू. ओके. Hope so. You all now clear with the concept. Now, next point is the reduction to the relational schema. Roll number 48, it's too late. Reduction to relational schema. Now we are now all aware about the how to draw, how to create ER diagram. This is the diagrammatic or pictorial representation of the our proposed database, which we will build or create in future. Now we are available. Our database ER diagram is available. Now we have to convert that ER diagram into a relational schema, that is nothing but the into a table. which are related to with each other. Then how to convert that ER diagram to the relational schema? These are the steps over here. Okay. See, the database can be represented using the notations, and these notations can be reduced to a collection of tables. As we saw, ER diagram is a collection of notation. It shows the rectangles for entities, attributes, with oval. For that we are using the oval. Like that, it's a collection of notations, and after that we can convert, or notation can be reduced to a collection of tables. In the database, every entity set or a relationships can be represented in a tabular form. Okay, every entity set or relationship set can be represented in a tabular form, in the form of table. Okay, so how to convert ER diagram into a relational table, relational schema or tables? Let's see. Now, suppose over here the ER diagram is given already. So let's discuss which are the entities present over here. These are related to the student database or college database, you can say. Who will going to tell me about the entities? Which are the entities over here?
Student, course,
Yes. Hmm.
uh, subjects,
Yes.
lecture.
Yes. Correct. Yes. These are the entity sets. Correct. Very nice. Now, for student, there are total four entity sets: students, course, lecturer, as well as the subject. Now, which are the attributes related to the student? Attributes. Tell me just few attributes. Attributes are nothing but the properties. Hmm? Properties of the entities.
Student name, age,
Mm-hmm.
uh, then hobby,
Yes,
date of
correct.
birth,
Yes. Simultaneously, for course, there are course ID, course name. Hmm? For the subject, lecturer ID, subject name. Okay. And for a lecturer, lecturer ID, lecturer name, course ID. Huh? These are the attributes. Now, within attributes, some attributes are underlined, right? Why it's underlined? What's what's the reason? Yes, anyone? Because these are the key
fear,
attributes. Yes, correct. Yes, these are the key attributes which uniquely identifies the entity. Okay. Some attributes, here hobby is the in the double oval. What's the type of hobby? Attribute type of hobby. It's multi-valued. Because of that, it has double oval. Hobby of the students may be more than one. Hmm? That's why it's double oval. Then age is in the dotted or dash because yes, anyone, why age is represented in the dash oval? What is the type of the attribute? We saw already the four types of attributes. No one knows because age is dependent on the date of birth of the student, DOB.
Derived.
So yes, yes,
Derived.
Pallavi. Yes, it is a derived attribute. It's totally depend on the birth date of the student. That is the DOB. Okay, this is all about the diagram, and here the relation is there. That is, students attends the course. Hmm? This is the many relations. Many students attends the many courses. Hmm? Many lecturer can takes many courses. Hmm? Lecturer teaches the subject. One lecturer teach one subject. Okay, like that. Here the relationship is shown. Now let's see the steps. How to convert the ER diagram to the relational schema. Okay. First of all, entity type becomes a table. See, first one, just note it down. Hmm? Whatever are the entities over here, these are become the table. Student is a one of the table, course, lecturer, subject. These are the four tables in our now database. In the given ER diagram, lecturer, student, subject, these are the individual tables. Then all single value attributes becomes a column of the tables. All single value attributes. These are the in the student entity, student name, student ID. See, student name, student ID. These as well as the uh, these are the different kinds of columns. Okay. Then a key attribute of an entity type represented by a primary key. Key attributes are what? Which are uniquely identifies the entity. So for ER diagram, course ID, student ID, subject ID, and lecturer ID are the key attribute for this entity. Okay, in a course entity, course ID is a key attribute. Huh? For a student, student ID is a key attribute. For a lecturer, lecturer ID is key attribute, and for a subject, subject ID is key attribute. Then the multi-valued attributes is represented by a separate table. In the student table, hobby is multi-valued attribute, so it is not possible to represent multiple value in a single column of the student table. Hence, we create a table student hobby with a column name student ID as well as the hobby. Using both the columns, we create the composite key. See over here now, multi-valued attributes. We can't show all these the values in a single column. Because of that, we are creating the separate table for the multi-valued attributes. Over here, hobby is the multi-valued attributes. Because of that, it's in the double oval. Okay. and we are creating the columns in the student hobby table, that student as well as the hobby. Up till now, is that clear how to convert, or it's too fast? Yes, please.
Clear, ma'am.
Composite attributes represented by a components. In the given ER diagram, student address is a composite attributes. It contains the city, pin number, door, street, and the state. In the student table, these attributes can be merged in an individual column. Okay, and then the derived attributes are not considered in the table. In the student table, age is derived attribute. It can be calculated at any point of the time by calculating the difference between the current date and date of the birth. Now, see the diagram. Using these rules, we can convert ER diagram to the tables and columns and assign the mapping between the tables. And table structure for the given ER diagram is as below. See over here now. Now, now student, lecturer, subject, course. Okay, as well as the student hobby. These are the five tables we are created from the ER diagrams, as well as the we mentioned the attributes as a column. Okay, student ID, name, date of the birth, street, city, state, like that. And we are showing the relationship in between using the arrows. Okay, hope so you understood this point. Just take a screenshot. Okay, here our unit 1 is over.